Let's take a quick look at properties of equality. If we look at this equation, we should be able to say, you know what, if I add 6 to this side to get rid of the 6, and I do the same thing to the other side, it's whenever we do the same thing to both sides that we have a property of equality. We're doing something that keeps both sides equal. So this would be the addition property of equality. And so we're going to see it in our notes as ape. If we do the addition property of equality, it's ape. This 6 cancels with this 6, so we get x is equal to 8, and that's our final answer because we added the same thing to both sides. So looky here, if we have this equation initially, do you agree we could subtract 10 from both sides? And look what happens. 10 minus 10 is 0, that's that additive identity, and x plus 0 is x. So we've solved the problem. Now officially what we've done is because we've subtracted the same amount from both sides, we could call this the subtraction property of equality. Some people would argue, well, there is no subtraction property of equality, so if you're doing subtraction, you should really see it as addition. Well, we could. We could make this plus a negative 10. These two guys would still add to 0. We could make this plus a negative 10. So officially, we have added the same amount to both sides, and then we can call it the addition property of equality. So I personally don't mind if you use either one of those two, but to be a purist, maybe you just say it's the addition property of equality. If you really want to impress your teacher, then here's what you can say. Once you apply the addition property of equality, you're going to be left with a 0 here. And why is it that x plus 0 is equal to x? It's because of the property of that number 0. It is the additive identity. So the additive identity property, if you add 0 to any number, you are going to get that same number. And that's what justifies going from this step to this step. Some geometry classes still insist that you go through and justify every step like that, and even this last step where you have the additive identity property. All right, if we go here to undo division by 5 to solve this, we're going to multiply both sides by 5. So as you can imagine, that is a property of equality because we're doing the same thing to both sides. This time we're multiplying both sides by the same number. So this is the multiplication property of equality. And then one more thing. If we do 5 times x, we get 5x divided by 5 is 1x. Justify this last step. How come 1 times x, if it's 65, is equal to just x? How come 1x becomes x? That would be the multiplicative identity property. That when you multiply anything by the number 1, it's that same thing. So if we want to show one extra justification of why we go from here to here, not only is it a multiplication property of equality, but we're also going to apply the multiplicative identity property. Then lastly, right here, if we're going to solve for y, we could multiply both sides by a certain value, and hopefully we recall from the other videos and what we've been doing, is that if you quickly multiply by the inverse or the reciprocal, this has to give you the number 1 because that's the definition of an inverse under multiplication. Whatever we do to the left side, we have to do the same thing to the right side to keep them equal. That's why it's called a property of equality. That would again be the multiplication property of equality. If we did the math on this and we cross cancel, ding, we get 28. And if 1 times y is 28, we know that y is 28 because 1 times any number is that number. So that officially would be the multiplicative identity property going from here to here. The big idea though, and what we need to know for now, is are using an addition property of equality or a multiplication property of equality. Just know we're doing the same thing to both sides, so it is a property of equality.